Okay, so last time we looked at combining logarithmics into one expression and then also expanding them out. This becomes in handy when we want to solve for a missing variable. So if we want to solve for t or solve for x, like what we'll do in 4.5. Just kind of see where we're at in the class. We're a little ahead of schedule as far as what section we're supposed to be covering. So originally I had 2 days for 4.4, but we're going to be able to probably finish that today. Friday we don't have class, and I'm probably not going to have an online lecture because I'll probably be done lecturing at that point over 4.5. So today we'll finish 4.4, introduce a little 4.5. I'm going to probably also pull up Alex to give you exposure to Alex type problems in each of those sections, so I can go through there and show you, this is how you input it. Maybe even do all of 4.4 today as far as Alex homework. After we come back from, or next week, so we only have today and then we have Wednesday. Monday we'll finish 4.5. I'll probably also give you a worksheet. I have, I put it on Blackboard, but I haven't printed it off yet, but I have the review. Here it is. It is the study guide. So this is posted on Blackboard. I'll also probably give it to you on Wednesday so you can look over all the topics that the long weekend we have. And then it also has some Alex type questions and some questions that would be free game for the test. And then last semester I taught this class, students just did really poorly on chapter 3. And I don't know if it was just being prepared, if it was coming right before Thanksgiving break because it was in the fall. And students had a lot going on. So I gave them this worksheet as well. And this is just some more practice. These would be very good exam-like questions. So that's also posted on Alex. So if you have a lot of time this weekend, because everyone has so much time on their hands, you can start looking at some of this stuff. I'll probably do some of them in class and just kind of highlight where students go wrong on the exam. And so all that is posted on Blackboard. So we'll have today's lecture, Wednesday's lecture. We will not meet on Friday, and then we'll come back on Monday, and I'll probably kind of summarize that review and summarize that worksheet on Monday, and then Wednesday will be our review, and Friday will be our test. So a week from this Friday will be our test over chapter 4. So last time we were talking about properties of logs, and we're using this property to either take an expanded expression and put it under one log. This can be beneficial when this is not a huge application, but when we need to calculate, if you're given log base b of 2 and log base b of 3, we want to approximate log base b of 36. So using factors of 36, we can write them as factors of 2 and 3. And since I know log base b of 2 and log base b of 3, I can calculate log base b of 36. So here your calculator's not going to help you because you can't plug in b. So here what we can, log base b of 36 can be written as log base b of 2 squared times 3 squared. Answer key here. All right, so I could write that as 2 squared times 3 squared. So when I multiply inside a log, if I want to take that outside the log, what am I really doing? Log of AB can be written as log of A plus log of B. The properties here. I can write this as log base B of 2 squared plus log base B of 3 squared. And then another property of logs has to do with powers, because I don't know what log base B of 2 squared is. I just know what log base B of 2 is. So the property of power says I can take this exponent and bring it down as coefficient. So this is really 2 times log base B of 2 plus 2 times log base B of 3. We know this. We know this. Log base B of 2 is 0.356. Log base B of 3 is 0.565. So plugging that in your calculator, we get 1.848 or 1.842.
You plug in log base 2 plus log base 3.
Yeah, so from here, I factored 36 into factors of 2 and 3. So that's 2 squared times 3 squared. So here, since it's 2 times 3, I can write that as log base 2 plus log base 3. Because properties of log state if I have log base B of A times B, I can write that as log base B of A plus log base B of B.
Yeah, I don't understand what you're entering in the calculator.
I took 2 times this number plus 2 times this number.
Okay.
So if I pull up my calculator and take 2 times 0.356 plus 2 times 0.565, I get 1.842. So let's look at the second example. I need to factor 24 into factors of 2 and 3. So what are my factors of 24?
2, 3, 8, 4.
Okay, so we say what?
I said 2 cubed times 3.
2 times 2 times 2 times 3. Right, 8 times 3 is 24. Or 2 times 2 times 2 times 3. So I can write that as 2 cubed times 3. You guys see that? So really I want to evaluate log base B of 24, but I don't want to write 24 as 24. I want to write it as factors of 2 and 3. So I have log base B of 2 cubed. Go ahead and write it like this. Times 3, which would give me log base B of 2 cubed plus log base B of 3, which would be 3 times log base B of 2 plus log base B of 3. So if I plug that in my calculator, I have 3 times 0.0356 plus 0.565, which would give me 1.633. So this is really just applying the properties of logs. Usually just using the multiplication or the power rule. The nice thing about 4.5 is you can use your calculator to calculate it because it's not going to be base B, it's going to be a number. So We're going to use our calculator to calculate log of any base. There's two approaches to the change of base formula. So if you have log base b of x, you can take log base a of x over log base a of b. A can be any number. It can be 10, it could be e. Most of your calculators only have log base 10 or log base e, the natural log. It doesn't matter which one you use, the ratio is going to be the same. Okay. Log of 36 over log of 2 is going to be the same as ln of 36 over ln of 2. So let's look at some of the estimations and then actually using the change of base formula in our calculator. We've talked about this before, but what would you estimate log base 4 of 153 to be if you needed to estimate it? What is log base 4 of 153 saying? Yeah, 4 to an x power is 153. So what's 4 squared? 16. What's 4 cubed? 64. What's 4 to the 4th power? 256. So if I was to guess x, what would I guess them between two consecutive integers? So x would be between 3 and 4, right? So let's actually use our calculator to calculate x. And the first one wants to use base 10. So if you take log base 10 in your calculator, write this out here. Log base 4 of 153 would be the same as log base 10 of 153 divided by log base 10 of 4. This is what's known as change of base. What do you get when you plug that in? That is correct. So if I plug in log base 10 of 153, I should get 2.18469,143. If I plug in log base 10 of 4, I get 0.60220599. If I leave that in my calculator, I get 0.36287. So this is just, do you know how to plug in your calculator?
No, I didn't go through all that.
Because your calculator gives you base 4, right? It gives you a way to input it. Most calculators don't. If most calculators, these are the standard, you have log and you have ln, right? So your calculator, the change of base is built in, so you don't have to do the ratio, but if you do the ratio, it's the same. Did anyone not get this in their calculator? Be very careful the way your calculator expects you to enter it, because some calculators you have to hit 153, then log. Like this calculator here, I would have to have 153, then I would have to hit the log. Other calculators, you hit log first, and then you can input 153. So if you're doing a multi-step, then you're dividing by, and you can do it all in one line. You can hit log 153 divided by log of 4, enter, and it should just give you the answer. So it turns out it doesn't matter if I use log or I use natural log. Here, with log base 4 of 153 is the same as ln of 153 divided by ln of 4. You guys confirm that in your calculator? I take ln of 153 divided by ln of 4, and I get the same thing as I take log of 153 divided by log of 4. eventually where this is leading to is we're going to solve for missing values of x, so I want to check it. So is this true? Is 4 to the 3.6287 power, is that approximately 153? I hope so. That's what I'm coming up with.
Well, can you check it in your calculator?
Yeah, so you hit 4 caret 3.6287 enter, and you should get something really close to 153. It is exactly 153. If you take more decimal places, the more accurate you're going to be. But if you round to 4 or 5 decimal places, you might be off a little bit. But it's a nice way to kind of check, did you complete that right? And that's what 4.5 is going to be a lot of. These expressions, get the answer, you can plug it back in the original and make sure the left-hand side equals the right-hand side. Any questions on that? The next 4 questions are along the exact same lines. What would you estimate log base 6 of 23 to be? Saying 6 to the x is 23. So 6 to the first power is 6. 6 squared is 36. So x is between 1 and 2. This is just somewhat nice. So plugging it in your calculator, if you don't get something between 1 and 2, you know you hit a wrong button in your calculator. You can go ahead.
Do you want me to show all this?
If it says use change of base, show the change of base. The application is going to end up in 4.5. We're going to have this long expression, and there's infinite amount of ways to write it since we can expand it, contract it, do various things. So I'll have you round it to 4 decimal places, and that's how you're going to plug. If the answer is log base 6 of 23, I just want to see you can write log base 6 of 23, and then you can plug it in your calculator and show me that. So you might not show me this step, which is fine. Yeah, but it's a very small part of the next section, being able to evaluate what's log base 6 of 23. And the reason why this is so powerful is eventually we're going to solve like expressions like this. We solve for that missing value. We take natural log of both sides, and we end up with ln of 2 plus 10x plus 1 ln of 3. And we're going to get x equals a whole bunch of crap. We're going to plug in our calculator and get a decimal approximation. So it actually turns out you're not out of benefit knowing that you could take log base 2 of both sides, and this would just cancel to this. And then you'll have log base 2 of 3, which you could get a different approach. And I'll show you that on Wednesday. There's so many different ways you can write it. It's all going to come down to a decimal approximation. So what do we get here? Log base 6 of 23. So 499,526, yeah. So 1.75. And that's between 1 and 2 is what we should expect. You can get the exact same thing by taking ln of 23 over ln of 6. So it doesn't matter in change of base if you take log or ln. You're still going to get the same ratio. You can check yourself by taking 6 to the 1.7499,526. Do you get 23? And you should. So let's look at some of the Alex assignments in this section. So there's 4 problems in 4.4. Find the missing values that make the equation true. Log base 3 of 8 minus log base 3 of 11 would equal log base 3 of, I heard someone say it, 8 over 11, right? Log base 11 plus log base what would equal log base 99? 9, right? Because you're looking at what times 11 is 99. Log base 9 of 25 would equal what times log base 5? 2, right? Because 25 can be written as 5 squared, and then that 2 is brought out front, right? So each logarithm in your answer should involve only one variable. Assume all variables are positive, and we want to expand this. So how would I expand log base z, I'm guessing is z, of x over 7? I wonder if this is saying z to the 7th power. That's what it's saying. So this is going to be, you're going to expand it out. So you're going to have 2 logs, right? So the first one would just be log of x. Let's go with this, of x. Am I going to add or subtract? Subtract what? Yeah, so I put this here, 7 log of z. It says it should only involve one variable. Each log should only involve one variable. Got it. Any questions on that? Difficult? It's just not yet. Really where it comes difficult is in 4-5, is because then you're going to solve for x. So we're going to use this to expand. So what's my first term going to be? Four log of x plus, not quite 3. I could say 3 halves. I could say 3 halves. 3 halves log of what? Z or y? Y, right? I could say z, but if I said z, what would my coefficient be? It would be 1/2, right? Because the z, all this is to the 1/2 power, so z to the 1/2 and y cubed to the 1/2, but y cubed to the 1/2 is y to the 3/2, right? So then that would still be plus, this would be 3/2 log of y. It should not matter what order you put that in, as long as you have the plus and the minus in front of the right corresponding variable. You guys see that? Here, we're going to combine it into a single log. So log base 2, right? Because that's not going to change. What do I have in my numerator? X to the 1/5, or the 5th root of x, right? Because this 1/5 is brought as an exponent. The 7 is brought as an exponent, and this you could say is brought as a -1, meaning it's going to go in the denominator, right? So w to the 7th z. Submit our homework there. So we should be able to see our answers are correct. That's 4/4. Let's look at some other Alex approaches. Since you guys are like, oh, did you get your Alex yet? That took what? 5, 10 minutes maybe. And also the quick retake should be on there for those that are more motivated by the quick retake. Let's look at 4-3. So rewrite as an exponential equation. What would be this one?
2 to the 4th.
Very good. 2 to the 4th is 16. Any questions on that? So we're kind of going backwards and reviewing here. Write as a logarithmic equation. Whoa. So if I was to take natural log of both sides, what would I have on this side? ln of e to the 8, which would just be 8, and this would be. So let me grab this here. And let's look at this in OneNote. So what I prefer on this one, take natural log of both sides. So ln of e to the 8 equals ln of x, right? This would be brought down up front, and it would be 8 ln of e equals ln of x. ln of e is 1, because e is the base of ln. So that would be your expression. You guys see that? So it's the same thing if I would have had 10 to the 8 equals x. What would this be? This would be log base 10 of 10 to the 8 equals log base 10 of x. This would be 8 equals log base 10 of x. You guys see that? A lot of times students have an easier way of going from logs to exponentials, but you're so used to seeing everything exponential, you don't like to go to logs. This is saying e to the 8 is some number. This is saying ln of some number is 8. They're inverses of each other. You guys see that? So here I have ln. Guess you can't type ln. ln of x equals 8. I take natural log of both sides. It's going to cancel the 8 or the e on the left, and I'm only going to be left with 8, and then I'll have ln of x. What is log base 2 of 16? 2 to some power of 16, right? What is 2 to what power of 16? 2 times 2 is 4, times 2 is 8, times 2 is 16. So we get 4 there. See that? You could plug it in your calculator. You're not sure. Take ln of 16 divided by ln of 2. What do you get? So that change of base formula is kind of nice now that we know it, because we can check ourselves, right? You can go to your calculator and take log or ln of 16 divided by ln of 16 divided by ln of 2 and get 4. But it means 2 to what power is 16, so. Here's a graph one. This is just moving the graph. If I have log base 4 of x is given, and I want to translate that to log base 4 of x plus 4 plus 2. So what am I going to do to my point here? I'm going to go to left 4 and 1, 2, 3, 4, up 2. So this is a little disconnected to what you would actually do on an exam, because on an exam I wouldn't necessarily give you the graph. I would just say graph log base 4 of x plus 4 plus 2. But here, granted I grabbed the right point there. I think there will be one where you have to actually enter it yourself. This one. So we have log base 3 of x plus 2. Right, so a couple ways we can draw this. We can plot at least 2 points on the graph and draw an asymptote and then click on the graph icon. So this is a log function. So is there a vertical asymptote or horizontal asymptote? Vertical. And where would my vertical asymptote be if it was just log base 3 of x? It would be at the y-axis. Do I shift it to the left or right any? In this log base 3 of x? No, right? I shift it up to the whole graph, but shifting a vertical asymptote up is not going to change where it's at, right? So I get my vertical asymptote, and then I can plot at least 2 points on the graph. You can do it with the pencil, or you can do it with actually plugging in the points, right? This is base 3, so what's my overall shape going to be? Something like this. That's what I should expect. So what do I want my first point to be? I can't plug in 0 because log base 3 of 0 doesn't exist. But I can plug in 1 because that is log base 3 of 0. So if I plug log base 3 of 1 is 0. So if I plug in 1, what do I get out of my function? 2, right? So I point 1, 2. Normally the point's 1, 0, right? But I'm shifting it up 2. So there's a few different ways you can look at it. So I plot that point. Then I need to plot one more point. The nice thing about, does this allow me to type in log? If I plug in point 2, let's plug in point 3 to make our life easier. What's log base 3 of 3? 1. So if I plug in 3, what should I get? 3. Just curious, if I plugged in 2, could I plug in 2 plus log? You can't plug in logs here. You can only plug in e's. So I wouldn't want to do that. But I only need 2 points to graph it. Grab my pencil. Oh no, grab my graph. So that's the exponential function.
So if you don't identify the vertical asymptote, it's just going to go there.
Yeah, it won't allow you to graph it. If you don't put a vertical or horizontal asymptote and you hit the graph, nothing will happen. So be careful though, you don't get disconnected from pencil paper, because when it comes to the exam, I'm going to say graph this and give me the domain and range. And on the graph, you need to label 1 point. And you could label either one of these points and show the vertical or horizontal asymptote. And here's the example of give the domain and range in interval notation. So let's go ahead and graph this and then do the domain and range, but you should be able to do the domain and range without graphing. So I have a vertical asymptote like I did before, right? Where's my vertical asymptote at? It's at x equals -1, right? Because that's where my function, that's where I would have a problem, because I can't plug in 0 there. And then place the first point. So if I need to place that first point, if I plugged in x equals 0, what would I get? Log of 0 is 1, -2, -1, right? So 0 minus 1. And you might, depending on, zoom in, but it should have like a magnet where if you get close to it, it's going to suck it to that point. Where did my graph go? Let's clear this. Oh, then I need to place a second point. So what would be a good thing to plug in here? X equals
1.
Oh, wait. What's log base 4? We plugged in x equals 0, right? So log base 4 of 1 would be 0. Log base b of 0 is 0. Or sorry, log base b of 1 is 0. So yes, it would be 0. So let me go back here. It would be 0 minus 2, right? 0. No, let me see. What do I want to do? Log base 4 of x plus 1 minus 2. So if x is 0, I have log base 4 of 1 minus 2. This is saying 4 to what power is 1? That would be 0, right? So this would be 0 minus 2, which is minus 2. And then what would be another good point to plug in there? 3, because this gives me log base 4 of 4 minus 2, which would be 1 minus 2, which is minus 1, right? So x equals 0 and x equals 3. So if I go back to my graph, make sure I have it on the right one. Minus 2 and then 4 would be minus 1. Submit the homework. Oh, cancel, yeah. And what would my domain be? So minus 1 to infinity. And what is my range? Minus infinity to infinity. Submit homework. Next. And we got partial credit here because the graph is incorrect. What did we do on the graph? Zero minus 2, right? It was 3, not 4. So we have a nice little quick retake here. And we can look at this one. Let's do this real quick. Log base 3 of x minus 1. So what is my vertical asymptote going to be at?
1.
It's going to be at x equals 1. The vertical asymptote is going to be where your log of it is at 0. Because log, you can never take log base anything of 0. Log base anything of 1 is 0. So here, my first point, if I plug in x equals 2, right? Point would be 2, 0. Right? Then if I plug in 4, in this case, right? I'd have 1. My domain would be 1 to infinity. And my range would be minus infinity to infinity. And then submit. Next. And we got our points there. Question. I didn't pass around the sign-in sheet. Yeah, let's do that real quick. I'll mark her here. So I know a lot of you kind of avoid Alex, but it's not that bad, right? He's a nice guy. 4, we did 4, 4, 4, 3, 4, 2. I think I've done some of 4, 2 in class. 4, 1 and 4, 2, we did a lot of that inverse functions, and I gave you that take-home quiz. The homework's going to be the same type, whether it's 1-to-1 or not. Remember, 1-to-1 follows a horizontal line test if it's 1-to-1. If it's vertical line test, if it's a function. So this is a function, but it's not a 1-to-1 function. This is a function, but it's not 1-to-1. This is a 1-to-1 function. I won't submit this one, but the 1-to-1 is horizontal. The function is the vertical. Like what x squared. X squared is an example of a function, but it's not a 1-to-1 function. It's not 1-to-1 because 1 squared is 2 and minus 1 squared is 2. So I have problems there. Here's the example of compositions, whether functions are inverses or not. We did some of those in class. in our notes. That review day, we did 4-1, 4-2, and 4-3. But so get in Alex and work on some of those problems. I didn't get to 4-5 today, but I think that's fine. We'll start working on 4-5 on Wednesday, and then also I'll give you a handout of that worksheet and the study guide, because after 4.5, that's the end of the material for this section. So then we'll have Monday and Wednesday to review, and your test a week from Friday. I will see you guys on Wednesday.